Hey everyone, and welcome back for another deep dive. Today, we're going to be exploring something pretty cool that's happening in the Ethereum ecosystem.
Okay.
A new development called Nuffle. And we've got a fascinating white paper to unpack here from Nuffle Labs themselves.
All right.
It's called Nuffle, Ethereum's Finality as a Service Layer. And it was just published on December 20th, 2024.
It's an exciting paper for sure. It dives into how we can achieve much faster and more secure communication between different rollups on Ethereum, which is essential for the future of DeFi and a truly interconnected blockchain world.
Okay, so before we get ahead of ourselves, let's do a quick recap on rollups for anyone who needs a refresher.
Okay.
Remember that highway analogy? Ethereum is the main highway. And it can get congested.
Right.
Rollups are like adding those express lanes.
Yeah.
Making transactions faster and cheaper.
That's a great way to visualize it. Essentially, rollups bundle transactions together off the main chain and then submit a proof back to Ethereum. This helps to scale things up massively. They take care of important things like the order of transactions, making sure data is available, and achieving consensus, all while inheriting the security of the main Ethereum blockchain.
Right, and remember that Dinket upgrade we talked about earlier this year, it introduced blobs, which are like temporary storage spaces for rollup data. This freed up a ton of space on Ethereum and led to a huge increase in transaction throughput.
Dencon was a game changer, no doubt. But as rollups have become more popular, we've run into a new challenge. Interoperability. It's like having all these amazing express lanes, but the exits and on-ramps between them are still super slow.
So we've got all these separate rollups doing their thing, but moving assets between them can be a real pain, right?
Right.
Especially with those optimistic rollups, where you sometimes have to wait days for things to finalize. It's not exactly ideal if you're trying to move quickly or take advantage of opportunities in the market.
Exactly. That's where Nuffle comes in. With its Fast Finality Layer, or NFFL. It wants to be the ultimate source of truth for rollup states, allowing us to verify transactions between rollups in just seconds. Imagine being able to move your assets between Arbitrum and Optimism almost instantly.
Okay, that's pretty impressive.
Yeah.
But how does it actually work? Does Nuffle set up its own network or something?
That's where things get really clever. Nuffle taps into EigenLayer, which lets Ethereum validators restake their ETH to support other services. Think of it like those validators are moonlighting as NFL operators, putting their ETH on the line to guarantee the accuracy of their attestations about what's happening on each rollup.
So they're putting their money where their mouth is. That seems like a pretty strong incentive to make sure they're doing things right. But isn't that still a bit risky? I mean, what if these operators make a mistake or even try to cheat the system?
It's a fair question, and that's why Nuffle has built in a robust security model. It distinguishes between two types of operator faults: safety faults, like providing incorrect information, and liveness faults, like being unavailable to do their job. To catch these faults, anyone can challenge an operator's attestation, but there's a catch. You have to put up some collateral to do so, which discourages frivolous challenges.
So you can't just go around accusing operators willy-nilly. You have to have some skin in the game. I like that. But what happens if a challenge is successful? Are there consequences for the operator?
Absolutely. If a challenge is successful, the challenger gets a reward, and the operator gets penalized, potentially losing some of their staked ETH. And the more ETH that gets staked on EigenLayer, the more secure NFL becomes. It's a really ingenious way to bootstrap security.
Okay, I'm starting to see how this all fits together. We've got these operators vouching for transactions, and there's a system in place to keep them honest. But we can't have all these updates constantly clogging up the Ethereum blockchain, right? That wouldn't be very efficient.
You're right. We need to keep things moving quickly. That's where NFL's messaging system comes in. Operators sign messages that attest to state changes, but most of this happens off-chain. It's like sending quick text messages back and forth, rather than writing a formal letter every time.
So it's fast and efficient.
Yeah.
But how do we make sure those text messages are secure and can't be tampered with? We need some kind of record, right?
We do, and then that's where checkpoints come in. Periodically, all those off-chain messages get anchored on-chain. Think of it like taking all those quick texts and summarizing them in a secure official record. This allows anyone to verify that the messages haven't been messed with.
Okay, so we've got this system for quickly and securely confirming what's happening on different rollups. But what about the developers who actually want to use NFL? Do they have to figure all this out themselves?
Thankfully, no. Nuffle has an aggregator service that acts like a one-stop shop for developers. It collects all those operator signatures, verifies them, and makes them accessible through a simple API. Developers don't need to worry about the complex cryptography or manage operators themselves. It's all handled behind the scenes.
So it's like Nuffle is saying, hey, developers, we've taken care of all the hard stuff. You just focus on building awesome applications. I like that. But how does this actually get integrated into the different rollups themselves?
Each rollup that wants to be part of the NFL party deploys a special registry contract. It's like the rollup's way of saying, hey, NFL, we recognize and trust your attestations. This registry contract can verify the signatures from NFL operators, which allows applications on the rollup to trustlessly confirm the state of other rollups.
Okay, so imagine I'm a lending protocol on Arbitrum, and I want to see if a user has enough collateral on Optimism. Instead of waiting days for a traditional bridge, I could use NFL to get that information instantly through this registry contract, right?
Exactly. And because NFL's security is rooted in EigenLayer's restaking mechanism, those attestations come with strong economic guarantees. It's a faster, more efficient, and more secure way to verify information across different rollups.
This is all very impressive. But I'm still trying to wrap my head around how this impacts the user experience. What's the so what here for someone who just wants to use dApps and move their assets around?
You're asking the right questions. Ultimately, what NFL is enabling is a much more seamless and interconnected blockchain ecosystem. Imagine a world where you don't even have to think about which rollup you're on. You just connect to your favorite dApp, and it works flawlessly, regardless of where the underlying assets or liquidity are located.
So it's like NFL is trying to create a unified experience across all these different rollups. That sounds pretty ambitious, but wouldn't that be amazing if it worked?
It would be a game changer. And we're going to explore some specific use cases in just a bit to show you exactly how NFL could revolutionize the way we use DeFi. But first, let's look at a simple example to illustrate the mechanics of NFL in action. Let's imagine a super simple protocol called Hello Protocol, where users can send hello messages between different rollups.
Okay, I'm game. Hello Protocol sounds friendly enough, but I'm guessing there's a bit more to this than just saying hi, right?
You got it. Let's say Alice is on Arbitrum and wants to send a hello message to Bob, who's hanging out on Optimism. Normally, this would involve bridging that message, which could take days with optimistic rollups.
Right, because we need to wait for the whole finalization process to play out. Not exactly instant messaging, is it?
Not at all. But with NFL, things get much snappier. Alice submits her hello message on Arbitrum, and it gets included in a new block. That block data then gets sent over to Near's data availability layer.
Hold on, Near's data availability layer. Now that's a new one for me. What's that all about?
It's actually a pretty clever way to ensure that the message data is accessible and can be verified by anyone. Remember how Ethereum's Demkin upgrade introduced those blobs for rollup data? It's kind of like that. NearDA provides a decentralized and efficient way to store all this information.
Okay, I'm starting to see the connection. So the message is recorded on Arbitrum and also stored on NearDA. What happens next?
Now those NFL operators who are running full nodes for both Arbitrum and Optimism step in. They check to make sure that the block data on NearDA matches what they see on their Arbitrum node. Once they've confirmed everything, they sign messages attesting to the new state of Arbitrum, which includes Alice's friendly hello.
So it's like having a group of trusted witnesses confirming that Alice did in fact send that message.
Exactly. And remember,
Yeah.
they've got their ETH staked on EigenLayer, so they're not messing around. They have a very strong incentive to get things right.
Right. Those ETH stakes are a pretty powerful motivator. But I'm still curious, how does Bob on Optimism actually receive the message? Is there a special delivery service for hello messages?
There is, and it's called the NFL aggregator. All those signed attestations from the operators get sent to the aggregator, which collects them until it has enough signatures to reach a quorum. This usually happens within seconds. Once there's a quorum, the aggregator packages up a nice, neat attestation that can be accessed through its API.
So the aggregator is like the messenger delivering a certified package of proof that Alice sent the message. I liked it.
Perfect analogy. Now, over on Optimism, the Hello Protocol smart contract can use this API to check if Alice's message exists. It just needs to send a query to the aggregator with a few key pieces of information.
All right, let me guess. It needs to provide the specific state root of Arbitrum, the block height where the message was sent, and the NearDA transaction ID where the block data is stored.
You got it. Oh, and of course, it needs the aggregated signature from those NFL operators. Think of it like a detective gathering all the evidence.
I love that analogy. So the aggregator checks everything out and confirms that there's a valid attestation from enough NFL operators for that specific Arbitrum state, which of course includes Alice's message. Then boom, Bob sees his hello.
Exactly, and it all happens in seconds. with the added security of EigenLayer's restaking mechanism.
Pretty neat,
right?
Seriously impressive. This simple hello example really helps to illustrate how fast and secure NFL can be. But let's get a little more real world here. How would this actually work for something more complex, like transferring tokens between rollups? That's what everyone really wants to know, right?
You're absolutely right. Let's say you want to move some ETH from Arbitrum to Base. This is where NFL can really shine.
Okay, I'm all ears. Let's say I have some ETH sitting in my Arbitrum wallet and I want to send it over to Base. How would NFL make that happen?
It all starts when you initiate the transfer on Arbitrum. Your ETH gets locked up in a special bridge contract on that side. Then NFL steps in to speed things up.
All right, I'm following so far what's going on behind the scenes with NFL.
Remember those NFL operators we talked about? They're constantly running their nodes, keeping an eye on things. As soon as they see your ETH get locked up on Arbitrum, they verify everything is legitimate and quickly sign attestations confirming the change in state. Those attestations include the fact that your ETH is locked and ready to be bridged over to Base.
So they're kind of like super fast, cryptographically secured escrow agents, making sure everything is on the up and up.
That's a great way to think about it, and because they've staked their own ETH on EigenLayer, they have a lot to lose if they try to cheat or make a mistake.
Right, those ETH stakes are a powerful incentive to stay honest. But how does my ETH actually get released on Base? It's not like those operators can just magically teleport it over, right?
Not quite magic, but pretty close. This is where Base's registry contract comes into play. Remember how we talked about each rollup having a special registry contract to interact with NFL?
Yeah, it's like the rollup's way of saying, hey, NFL, we trust your judgment.
Exactly. So the bridge contract on Base receives the aggregated attestation from the NFL aggregator confirming that your ETH is indeed locked up on Arbitrum and ready to go.
And then the registry contract on Base steps in to double-check everything.
That's right. It verifies all the signatures, makes sure enough operators have signed off, and then gives the green light to the bridge contract to release your ETH on Base.
Wow, so my ETH just appears on Base almost instantly. No more waiting days for things to finalize.
That's the power of NFL. It's like a high-speed rail for your crypto assets.
This is seriously cool. It sounds like NFL could completely change the way we use bridges. What about existing bridges like Stargate or a Cross? Would they become obsolete?
NFL definitely poses a challenge to those existing bridges. It offers a much faster and potentially cheaper solution thanks to EigenLayer's shared security model bridges that rely on their own separate consensus mechanisms, or expensive Oracle systems might struggle to keep up.
But what if something goes wrong with NFL? Wouldn't we still need those older bridges as a fallback option?
That's a valid point for really high-value transfers or situations where you absolutely need certainty. It might be wise to use both NFL for speed and a traditional bridge for final settlement. It's always good to have multiple layers of security and redundancy.
Okay, that makes sense. So we've talked about how NFL can revolutionize bridging, but what other exciting possibilities does this technology unlock?
The potential is huge. One area that I'm particularly excited about is cross-chain lending. Imagine being able to use your crypto assets as collateral on one rollup and instantly borrow different assets on a completely different rollup.
Wait, are you saying I could put up my ETH on Arbitrum as collateral and then immediately take out a loan in USDC on Optimism, even though they're totally separate blockchains?
Exactly. With NFL lending protocols can verify your collateral position almost instantly, making cross-chain lending fast and efficient. It would break down those silos of liquidity that exist today.
That would be amazing. It sounds like NFL could unlock a whole new wave of innovation in DeFi. What about decentralized exchanges? Could they benefit from this too?
Absolutely. Imagine a DX that's deployed on Arbitrum, where liquidity is the deepest but accessible from any rollup through NFL.
Yeah.
You could place your trade on your preferred rollup, but the actual swap would happen on Arbitrum, leveraging its deep liquidity and efficient pricing.
So no more having to bridge my assets over to Arbitrum just to use that DX. I could just interact with it directly from, say, Optimism or Base.
Exactly. NFFL would handle all the behind-the-scenes state verification, making the whole process seamless and secure.
This is blowing my mind. It's like the dream of chain abstraction is finally becoming a reality. But what about the developers who build these dApps? Would they still need to deploy their DX on every single rollup? That seems like a lot of work.
That's what's so brilliant about this with NFL. They wouldn't have to, they could choose the best rollup for their primary deployment based on things like gas costs or the development ecosystem, and then reach users across all the other rollups through NFL. It's like deploy once, use everywhere.
Wow, that's a game changer. NFL really does seem like it could transform the way we think about building and using dApps. It's exciting, but also a bit intimidating. Were there any downsides or risks we should be aware of?
It's important to be realistic. NFL is still a very new technology. One challenge is its reliance on EigenLayer. If EigenLayer were to run into problems, it could impact NFL.
That's a good point. NFL's success is tied to the success of EigenLayer. Are there any other potential challenges?
Scalability is another big one. As more and more rollups come online and the number of transactions explodes, NFL needs to be able to keep up. It's a fascinating challenge for the developers to tackle.
It sounds like there's still a lot of work to do, but even in these early stages, it's clear that NFL is a major innovation in cross-chain technology. It's amazing to see what the Ethereum community is capable of.
I agree. NFL is a testament to the ingenuity and collaborative spirit of the Ethereum ecosystem. It's a bold experiment, but one with the potential to reshape how we think about blockchain interoperability.
Well, folks, we've reached the end of our deep dive into Nuffle. We've covered a lot of ground, from the basics of rollups to the intricacies of NFFL and how it could revolutionize DeFi. I don't know about you, but I'm feeling pretty energized by all the possibilities. What are your final thoughts?
It's definitely an exciting time to be following Ethereum. We're witnessing the birth of a new generation of cross-chain technology. Who knows what the future holds, but I'm incredibly optimistic.
Me too. It's not just about the tech. It's about building a more open, accessible, and interconnected financial future. And that's something worth getting excited about.
Couldn't agree more.
If you're as intrigued by Nuffle as we are, we encourage you to check out the full white paper from Nuffle Labs and explore the exciting world of cross-chain innovation on Ethereum. Until next time, happy diving.